Hey everyone, we're going to find each stationary point and determine the type. There's 3 types. We'll go over that. And then also find the coordinates of the points where the curve, this curve here, meets the x and y axis. And sketch the curve, and we can check with our graded graphing display calculator if necessary. So basically, these are the steps you take. These are the 3 types of inflection points: a maximum, minimum, and a point of inflection. And this is where it's concave up and concave down. And we'll talk about this one because this one does have an inflection point. So the first thing we do is do step 1. We're going to find the derivative of y with respect to x and set it to 0. So let's take the derivative of y with respect to x, and that's going to give you 3x squared. Now set this to 0 and we get x is 0. So when x is 0, plug in 0, you'll get 1. Whoops. So plug in 1. Now we have to determine if this point is a max, minimum, or point of inflection. And to do that, we're going to take the second derivative and substitute each value to find the kind of stationary point. So take the second derivative of y and set that to 0. Well, the second derivative is 6x. Set it to 0 and we still get 0. Now that's going to tell us if it's 0, and it's right here, I should have made this bigger, it could be either a point of inflection or a minimum or a maximum. And since we have 0, what we're going to do is look and see what's going on if x is negative and plug it into that. So if x is negative, then our derivative of y with respect to x, which equals 3x squared, plug in a negative value, and you're going to get positive. All right, and now let's see if x is positive. When you do the positive part of this, you're still going to get positive. Since there's not a switch from positive to negative or negative to positive, that means it's a point of inflection. They stayed the same. If they were both negative, they would both be points of inflection. So for it to be a max or min, one has to be positive, one has to be negative, and it's not. So this is called a point of inflection. Now, let's look at that. This is like an inflection point, and our graph looks a lot like this. So there is the inflection point. They were both 0 in here. An inflection point is where you're concaving down. Now the slope is still down, but it's going to concave up. So this one, this one's hard to see. This one's concaving up. Then after this point of inflection, it's concaving down. Concave up. This one's concaving down. So this is concave up, and this is concave down. So it's just the shape of the curve. So now let's just find the parts. We already know that we have 0, 1. We already know that's our y-intercept because that's x is 0. So let's find when y is 0, what is x? So when y is 0, what is x? So x cubed equals -1. You cube root both sides, and you get x equals -1. So this will be -1, and that's where it crosses or meets the x and y axis. So This point here is where it meets the x-axis. That's 0, comma, or -1, comma 0. This is where it meets the y-axis. And this point of inflection here is kind of flat in there, and it concaves down to get to this point, then it concaves up. And that's it. Thank you. Have a nice day. Bye-bye.